Hello, and welcome to this tutorial on how to do sorting in GameMaker. What sorting is, simply, is to take an array like this, an unorganized set of numbers, and to organize it. In this case, I'm going to be organizing it from least to greatest. So I'm going to take this array, which is 10, 7, 8, 9, 1, 5, and try to make it into an array that says 1, 5, 7, 8, 9, 10. And I'm going to use sorting methods to do that. The two sorting methods I'm going to be showing are the bubble sort and the quick sort. And what I've said here is this is the efficiency, or like the speed of the code itself, which if you don't understand that notation, you don't need to worry about it. But the point I'm trying to make here is that bubble sort is very simple, very easy, but very slow. Quick sort, it can be that slow, but that's only in the worst case scenario. The average and the best case scenario is much faster. The draw, of course, is just going to draw the array. This is just so you can like visually see the array here, see the 10, 7, 8, 9, 1, 5 of the array, so that we can test the different sorting methods. And these sorting methods are going to be in the form of scripts. So the first one we're going to do is bubble sort, right here. And this bubble sort takes in an array, it's going to be notated like that, not bibble, bubble. And then I'm just going to write the description and the parameter here, which are just so that when you reference back to it as a script later on the bottom here, it will show up with like put in an array. So you can remember that that's what you need to put in for this exact script, and you don't need to keep that on your memory. And the first thing we're going to do is we're going to get the array length, which in GameMaker is a very long line of code, and so I just like setting a reference variable there with length. And the way this array works, or the way the sorting works, is as you can see here, this is it visualized basically. It goes through it, so it loops it for like these I times, and then inside of that I, there's a J loop there. And what it does is it slowly moves it until like right here you have 3, 1, and then you move the 1 over, and you do it like that and that and that, and you slowly go bit by bit until everything's organized. By basically right here, all you're doing is you move the 3 over, right? So the 3 is on top, then you move the 5 over, and then it says these two are fine, but then the 8 goes over like that, and the 2 goes over like that, and the 4 goes over like that, and it keeps going, and so it sort of creates this giant like trapezoidal shape basically. It's very slow, as you can see, very obviously slow and iterative, but it's very, very simple to write. So that's why you might, if all you're looking for is a simple sort that you're going to use once and basically never again, this is probably your best bet, because it's the speed of it being generally kind of slow is really not a big deal unless you're dealing with like hundreds of objects, or if you're looking at more than just a number. And then I'm going to do an I in the first loop, which is, as was shown here, is the I here. I'm going to do an H instead of a J though, because I personally prefer to use H. You can use whatever variables you want. Minus I and minus 1, and then H++. And then inside of here is the part where we're going to actually start sorting, and that's just an if statement, which is argument 0 of H is more than argument 0 of H plus 1. Then you swap between position H and position H plus 1, because if H is more than H plus 1, then you're gonna, that means basically like on here, 5 is more than 1, and so you want to move the 1 over here and the 5 over there. So you can slowly start moving the 1 towards the front and the 5 towards whatever position it is in the middle or the back. And so that's what this code is doing right here, and this is just, the 2 for loops are of course to iterate between the entire set of code. And so then it's going to take the temporary argument of 0 and h, which is the h position, and it's going to say argument 0 at h, that at operative being important, because that's how you actually change a array inside of a script. Otherwise, it won't work, so you need to have that at operative there. That's important. And then argument 0 at h plus 1 equals temp. Not me to do that, but there we go. And that's it. That's the whole code for bubble sort. Isn't that easy? Very, very simple. And now I will show you. As you can see right here, 10.7.8.9.1.5. You can run it 10.7.8.1.9.1.5. But now we can just do the script of the bubble. And as you can see down here, that array that I defined earlier. And the array is of course going to be the array test. And boom. The bubble sort worked. It becomes 1, 5, 7, 8, 9, 10. So if all you're looking for is a simple and easy script that works, your bubble sort is your best bet. It's very good. But if you need that extra speed, let's move on to the quicksort. Now the quicksort is a bit more complicated, as it actually uses 2 different scripts. A partition script and a sort script. The sort script needs the partition script to work, which is why you need to write this with 2 scripts. It is also called recursively, which might be something that you might not understand. That just means that the function, or in this case the script, calls itself, so that it loops through itself. So right here we're going to do a partition script first, which the partition need, and how this actually works, by the way, is, see, in this example, you have an array like that with 10, 80, 30, 90, 40, 50, and 70. The partition point becomes 70 here, and so then what it does is it moves it over, basically, and moves everything under 70 in front of it and everything over 70 behind it. So then 70 becomes sorted right here, and then we look at 80 and 90, and we partition around 80, and we say nothing is in front of it, so 80 is sorted, and 90 is in back of it now, so then it goes over here, and then that becomes sorted because it's alone. And you keep doing that over and over again until you go down. And as you can see, this is of course going to be much more efficient than the bubble sort. However, it is going to be a bit more complicated. And so, let's do it. The partition code is actually going to take multiple things in here, which is script partition. That's going to be the array, the low point, and the high point. And it's going to have a description, a partition, array, low, high. With the parameters, again, these are all just so that they show up down here. Again, you don't need to have these. They're just for my use, but that first line of script partition, right here, you do need to have that. That is necessary. So all the parameters and description are set up. And now, what do we start doing? Well, we need to take the last element of the array as the pivot, and then place all smaller elements to the left and all greater elements to the right. So, first thing we gotta do is declare a pivot point. We're going to call it variable pivot, and it's going to be argument 0, which is the array, at the high point, which is argument 2. Pivot point to modify array over. And now we get a variable I, which is just going to be a index, hence I, later on for the actual for loop. It needs to be set -1 here, because we're going to add 1 to it before we use it the first time. And so the first time we want to use it, we want it to be 0. But since we're going to add 1 to it before we use it for the first time, we need it to be at -1 so that the first time is actually 0. And now what we're going to do is we're going to do the actual code here. We're going to do for j equals argument 1. And this is why I said I didn't want to use j before, because I use it here and it's a mess. Gotta have a separate thing, right? For j equals the argument 1. J, as long as j is less than argument 2, keep adding elements of j. And then what you gotta check is if current element is smaller than or equal to the pivot, which is what we were checking over here. So like smaller than 70 or more than 70. And so if argument 0 of j, which of course is going to be the array at the point of j in this array, or the array at the point of j within these iterations of the for loop, is less than or equal to the pivot. If it's equal to, you also want to put it in front, just to make it easier. I++, again, like I was saying over here, this is why we need to have it at -1, because we're going to add 1 to it immediately. And then you're going to swap the array of I and the array of j. Then temp equals argument 0 I, this is the same sort of just swapping code I had before. You could actually make a swap script if you wanted to, which just takes two arguments and then swaps them and returns the 2 arguments swapped. However, I'm not going to show that in this. This is just the same code again from the last time, only with different variables inside of the array. And again, you're going to need that add operative to actually make it change it. And so all we're doing is setting the temp here, and the argument equals the other argument, and the argument equals the temp. So that's just going to actually swap it. And so that's all this is going to do. If the current element is smaller than the pivot point, put it in front of the pivot point. Easy. Well, actually, more importantly, you're actually just putting it at the beginning of the array, essentially. You're swapping it with a point at the beginning of the array. And the reason why you're doing this is that basically everything in front of the pivot point is just being shoved into the beginning of the array, and then we're going to shove the pivot point directly after that, and then everything after the pivot point is going to be already things that are larger than the pivot point, so we don't even need to worry about that. And then we're going to swap this is actually putting the pivot point down, the I+1, which is everything, so all of this is going to stop at I, right? The last thing lower than the pivot point is going to stop at I. And so the pivot point where that needs to go is at I+1, so we're shoving the pivot point into its place now. And we're swapping that with the array at the high point, which is the same thing as the pivot. They're the same thing, because remember we declared that up here that they're the same thing. And so we're just going to say temp equals argument 0 at I+1, which is wherever we want to shove it, and argument 0 at I+1. So now we're resetting that point, again with the at operative, this is necessary, at argument 2. That's not argument O, it's argument 0. Silly me. Not R0, jeez. And argument 0 over here at argument 2 equals temp. And so now they are swapped so that the pivot point has been shoved in front of all the things that are less than it. And we return this return statement, you might think, why are we returning anything? It's for the actual sorting method, because this is just a partition method. The sorting method is much smaller, so don't worry about that, but it needs that return statement. So now we move on to the actual sort, which I'm going to call qsort for quicksort, because I'm not going to write down quicksort. That's too many words. Programmers don't use words. We use random arrays of letters. And hi, it takes in the same methods as the bubble sort did. And the description is going to be, let's call it qsort with the array low and high with the parameters of array low and high. So the same parameters, the same different description, just with the name, and a different title up here, just the name. But other than that, almost the same as partition, right? But it does something very different at the actual thing. So now what you're going to do is we're going to start recursively calling it. So basically what we've done so far, what we've done so far is we've taken this and we've partitioned it around the 70, right? So now this is organized as an array that says 10, 30, 40, 50, 70, 80, 90. And now what we need to do is actually start saying, now we got to partition this, and we got to partition that, and we got to have all of that be working together, basically. So adding it all together and making that work. So we're going to say, if argument 1 is less than argument 2. The reason why we're just saying an if already is that this is going to be called recursively, which is going to loop it. Variable of part ref equals scr underscore partition with argument 0, argument 1, and argument 2. You never call partitioning the end. You never call partition in your actual object or in any object or like other place. You only call partition through the quicksort script. That's the only purpose of the partition, is to be used with the quicksort. You could combine them into a single script, but generally it's best if you keep them separate. That's just going to make it simpler, especially for debugging, and more efficient. Recursively sort the elements before and after the partition, which means scr sort or qsort. Which, look, there it is, the array low high that I just said. So helpful. Argument 1 and argument 2. Well, actually, not in this case. In this case, what you're doing is before and after the partition, so we need to find that partition point, which is why this is, the partition returns i+1, which is the position of where the partition point is. And so what this is going to do is it's going to now recursively sort everything in front of it and everything behind it. Supposed to be a minus. There you go. Oh, that's a period this way. I was like, what the fuck? Oh, okay. It goes through and sorts it all. Argument 0, everything in front of the part ref and everything after it, everything in front of the partition, everything after the partition, and then it's going to partition it again, and then do that again over and over and over again until basically, like it is here, instead of being a bunch of arrays, it becomes just a set of single things. A 10, a 30, a 40, a 50, a 70, an 80, and a 90. And that's not exactly shown here, but that's what it does. And then once it has all of that, it's going to be done, and it's going to say, okay, I'm done now, and return that. And that's all of the code we actually need here. Weird. Oh well. All you're going to say up here is SCR underscore, not bubble. We're doing the quick sort now, which is going to take the array, which is array test, and it's going to take the low point and the high point, which is going to be 0 is the low point, of course, because you can actually say if you want to only sort part of the array, which you can do here. I'm sorting the entire array, however, so I'm going to do this. Oh, there you go. Yeah, that was a stupid mistake. Yeah, I meant to say +1. Oh well. So that's it. Also, this error makes no sense. It works, so whatever. That's it. It works now, as you can see. So all you gotta do here is just, this is the entire sort method, which takes the partition point, as I was saying earlier, indexes around there, and then recursively sorts it by going through everything but that index point and doing it over and over again until you have just a single one left, and then that actual partition code is right here. And the reason why this is more efficient than the bubble sort is that you're only looping through this as many times as it takes to get it down to one element, and every time you loop through it, you're looping through it with one less element. Instead of looping through the entire thing every time. So that's why it is much more efficient than bubble sort, even though bubble sort seems like it might be, with how just like, wah, it is.